Hello there, this is Lawrence, KL7L, and a series of videos we're investigating how to set yourself up on the new 630 meter or 220 meter handbands. Today we're going to investigate the 137 kilohertz transmitting loop that we're using here at KL7L. We've been using this style of antenna for a number of years under our experimental call sign. And here we've just erected this this loop antenna. Now, why do we lose loops which are particularly ineffective under normal circumstances versus a Marconi? Well, we're in a forest, and with Marconis, which are typically high impedance antennas, the losses through these trees tends to be fairly high. Excuse the aircraft noise. We're at the end of a runway. So here at KL7L, what we're using is a thick piece of cable. This is 4TFFN. It's nylon sheathed. It's about 0.1 of an ohm right around this this loop. It goes up a tree to 65 feet, along for 180 feet, and then down, and then the return is about 9 feet above the ground here. And the reason we're 9 feet above the ground, which is this wire here, goes along the ground back to the other end, where it goes up a tree and then up over these trees really high, and then down and then back to here, is if you have less than 9 feet, the capacitive effects of this wire against ground is quite high. So if you have any changes in the weather or the ground conditions, it actually changes the loop's tuning. So this is effectively just a loop of very low loss wire, insulated over the top of the trees, and it's resonated. This has an inductance, 200 microhenry, and then we resonate it with a series capacitor, and this series capacitor is in fact a bank of capacitors, and they're all designed to be low loss at 137 kilohertz, which isn't easy. Now, to resonate it, to transform this impedance, we use a big lump of ferrite, which you see, and it's 3 stacked FT290-77 types of core, and they're fairly low loss at 137 kilohertz. And we have 2 turns on this side, and we have a switch that we can switch in the ratio. And at the moment we're using about 13 turns to 2 turns to get it to 50 ohms. So 50 ohms this side, 13 turns to 2 turns. And obviously we use thick as wire as possible, and we're expecting, well, we know we get with this loop, which is fairly low resistance loop, we get about 40 to 50 amps of antenna current. So there's 40 to 50 amps of current running through all this stuff here at 137 kilohertz. So you have to be very careful of losses. You don't want to put any high resistance in joints, and you have to be careful to make sure these capacitors are chosen to be a low ESR or dissipation factor at these frequencies. And you may have to down rate or parallel a number of capacitors here to get this value. Here we need about 8 nanofarad, 8,000 puff to get it right. So what does it look in true terms? Well, now comes our loop wires, one loop going up and over the tree that way, and it comes in back in through here, and we just keep it insulated away from the earth. We'll take the lids off the tuner here, and it's below freezing, so I'm to be a bit careful. So the coax comes in here, 50 ohms. This is LMR 400, about 300 feet of it. And this is the switched primary on the 50 ohm side, and we can switch the number of turns from anything from about 9 through to 15 with this big 20 amp ceramic switch. And at the moment we are about 13 turns on this side, and then this big thick stuff here, which is this monster wire, is the other side of the transformer, and that's 2 turns, and 2 turns in series with the loop. And across the loop is this bank of capacitors. These are low loss mica capacitors, Sangamo transmitting capacitors, and what we do is we share the current flowing through the loop by capacitive dividing, if you like. So small amount of current goes through each of these capacitors, and it stops the heating of the capacitors and the mistuning as you change the temperature. Sometimes the capacitance varies, but we share the current across these capacitors so that doesn't happen. And you can see that we're using a very large strap here to keep the RF losses very low. And then we tune it to resonance. So we've got these bank of capacitors, 7 nanofarad or so, and then we tune the final bit out using this vacuum variable, which is 22,000 puff, and we drive it from the shack with DC, which we can switch the DC direction from this cable coming in from the shack. And if you look at my other videos, you'll see the other end of how we do that. And then we can drive the motor this way, which moves the capacitance in and out to bring it to resonance. Very high Q antenna. It sounds, as you tune through, if you put this on the connectors to a receiver and you tune through it, it sounds like a very narrow SSB filter. To measure, to make sure that you're actually on resonance, we current sense on the loop side, and it transforms this sensing device here, and we can actually read from 0 to 100 amps. 100 amps of RF on the loop side, and on the 50 ohm side it's 0 to 9 amps. So for around about a kilowatt in RF, we're lucky to get 1 or 2 watts ERP or even EIRP out of this sucker, depends. Being a loop, it transmits positive. The loop sort of goes this way and up over the trees. It fires in the plane of the loop, that's Japan that way, and the lower 48 states over that way, and it has a null to the north, which is that way towards the mountains, and to the south. So this is the transmitting loop here at KL7L, and just hope in a series of videos, this is one way of trying to get a signal out on 137 kilohertz. Now you could actually use this on 630 kilohertz as well. You'd have to change the ratio of your toroids and maybe change the type of toroids, and it's something like 9 to 10, 9 on that side, 10 on that side, or vice versa. And then the tuning capacitance, because we're nearly at a quarter wave at 630 meters, the tuning capacitance is much less, probably less than a couple of hundred puff. So you did take out all this capacitors, so you could try doing that. Anyway, but this is the 137 kilohertz version, and at 1 kilowatt continuous transmit carrier, all these components stay fairly cool. The warmest would be this big lump of ferrite here. Anyway, 73s from the wilds of Alaska, the Talkeetna Mountains, the frozen lake, and happy Guy Fawkes Day in the United Kingdom. Saturday the 5th of November 2017, KL7L. Thank you.